In the previous lecture we covered the ranges related to materials, thicknesses, and diameters. In this lecture we move into the essential variables related to the welding process itself, the parameters that must stay within the qualified ranges for the WPQR to remain valid. These are the variables you and your welders interact with every day in production. Welding positions, Clause 8.4.2. When neither impact nor hardness requirements are specified, welding of the test piece in any position, plate or pipe, qualifies for welding in all positions of the same type. So a flat position plate weld qualifies all plate positions, and a fixed pipe weld qualifies all pipe positions. When impact and hardness requirements do apply, a single test piece in one position cannot cover all positions. This is because heat input varies with position. Vertical up welding typically produces higher heat input than horizontal, which affects toughness and hardness results differently. The rules are: impact test specimens shall be taken from the weld in the highest heat input position. Hardness test specimens shall be taken from the weld in the lowest heat input position. To satisfy both simultaneously, two test pieces in different welding positions are required. For plate butt welds, the highest heat input position is typically PF, vertical up, or PA, flat, and the lowest is PC, horizontal, or PE, overhead. A fixed pipe weld, where the pipe does not rotate and the welder moves around it, naturally covers multiple positions in a single test piece. Vertical down welding, positions PG, PJ, and JL045, must be qualified by a specific test piece in that position. A vertical up qualification does not cover vertical down. Type of joint and weld, Clause 8.4.3. We touched on this in Lecture 3, but let us review the specific qualification hierarchy. At Level 2, full penetration butt welds qualify full and partial penetration butt welds, and fillet welds in any joint type. Butt joints in pipe qualify branch connections with angles of 60 degrees or greater. Fillet welds qualify fillet welding only, they do not qualify butt welds. Welds made from one side without backing qualify welds from both sides and welds with backing. Welds made with backing qualify welds from both sides, but welds made from both sides without backing do not qualify welds with backing. When impact or hardness requirements apply, you cannot change from a multi-run deposit to a single-run deposit, or a single run on each side, for a given process, or vice versa. This is because single-run welds introduce much higher heat input in one pass, with significantly different Has characteristics than a multi-run weld. Build-up welding, where weld metal is deposited on a surface to restore dimensions, is qualified by a butt weld test piece. And at Level 2, buttering must be performed on a separate test piece in combination with the butt weld. Filler material, Clause 8.4.4. The filler material qualification rules differ significantly between levels, as we covered in Lecture 3. Let us consolidate the key points. At Level 2, filler materials cover other filler materials as long as, according to the designation in the appropriate international standard, they have equivalent mechanical properties, the same type of covering or flux core, the same nominal chemical composition, and the same or lower hydrogen content. This gives more flexibility than the Level 1F number system, but requires careful comparison of the designation. The critical Level 2 exception, when impact testing is required by the application standard at temperatures below -20 degrees Celsius, for processes 111, 114, 12, 136, and 132, the range of validity is restricted to the specific manufacturer trade name of the filler material used in the procedure test. To change manufacturer, an additional test piece must be welded at the maximum qualified heat input, and only weld metal impact specimens need to be retested. This exception does not apply to solid wire and rods with the same designation and nominal chemical composition. Filler material size, Clause 8.4.5. It is permitted to change the size, meaning the diameter, of the filler material, provided the heat input requirements of Clause 8.4.7 are satisfied. When neither impact nor hardness testing is required, there is no limitation at all on filler material size. Type of current, Clause 8.4.6. The qualification is given for the type of current, alternating current, direct current, or pulsed current, and for the polarity used. For process 111 only, manual metal arc welding with covered electrodes, alternating current also qualifies direct current in both polarities, unless impact testing is required. This is because the AC to DC transition for covered electrodes has minimal effect on weld quality for most applications, but can have an effect on toughness when very low temperature impact performance is critical. Heat input, Clause 8.4.7. Heat input, or arc energy, is one of the most important essential variables in procedure qualification. It fundamentally affects the cooling rate of the weld and has, which in turn determines the microstructure and mechanical properties. The standard allows either heat input or arc energy to be used. Arc energy is calculated per ISO TR 18491. When using heat input, the K factor from ISO TR 17671-1 must be applied. This accounts for the thermal efficiency of the specific welding process. The choice of calculation method, heat input or arc energy, must be documented. At level 1, when impact requirements apply, the upper limit of qualified heat input is the maximum heat input actually used when welding the test piece. No tolerance above this maximum is permitted. At level 2, more nuanced. When impact requirements apply, the upper limit of qualified heat input is 25% greater than that used when welding the test piece. When hardness requirements apply, the lower limit of qualified heat input is 25% lower than the test piece value. If the procedure test was performed at both a high and a low heat input level, all intermediate heat input levels are also qualified, and it is not necessary to calculate the heat input of every individual run. For covered electrodes, the heat input average shall be calculated for each electrode diameter used, to define the qualified heat input for that diameter. For process 111, the heat input may also be measured indirectly using the runout length, the length of weld produced by the melting of one electrode, per unit length. This is a practical field measurement when precise electrical measurements are not available. Preheat and interpass temperatures, clauses 8.4.8 and 8.4.9. For preheat temperature, a decrease of more than 50 degrees Celsius from the recorded preheat temperature on the WPQR requires requalification. A decrease in preheat is only permitted if the requirements for preheating, particularly regarding combined thickness, are still satisfied for example, ISO TR 17671-2. The preheat temperature may be specified by a material datasheet and will depend on material thickness. For interpass temperature, an increase of more than 50 degrees Celsius in the maximum interpass temperature reached during the welding procedure test requires requalification. At level 2, for material groups 8, 10, and 41 to 48, the upper limit of qualification is the highest interpass temperature actually reached during the test. This limitation does not apply when a WPS is qualified with a post-weld heat treatment above the upper transformation temperature, or when an austenitic material is solution annealed after welding. An important special case, if an intentionally increased preheat temperature is applied during the capping passes to reduce has hardness, this is considered an essential variable. Both the minimum preheat applied overall and the preheat applied during capping must be recorded on the WPQR. Post-weld heat treatment, clause 8.4.11. Addition or deletion of post-weld heat treatment is never permitted, full stop. If your procedure test was done without PWHT, you cannot apply PWHT in production, and vice versa. Separate qualifications are required for each of the following PWHT conditions: stress relieving below the lower transformation temperature, normalizing above the upper transformation temperature, normalizing or quenching followed by tempering, and PWHT between the upper and lower transformation temperatures. At level 2, the validated PWHT temperature range is the holding temperature used during the test, plus or minus 20 degrees Celsius, unless otherwise specified. Heating rates, cooling rates, and holding times are also recorded where required, related to the production product. Process-specific variables, Clause 8.5. Submerged arc welding, Clause 8.5.1. At level 2, each variant, 121 to 126, must be qualified independently. Any change in the number of electrodes requires requalification. Addition or deletion of cold wire or hot wire additions requires requalification. A change of more than plus or minus 10% in the ratio of supplementary filler material to electrode requires requalification. The qualification is restricted to the specific manufacturer, trade name, and designation of the flux used in the test. GMAW, Clause 8.5.2. Shielding gas. Qualification restricted to the nominal composition use. A deviation of up to plus or minus 20% relative in the CO2 content is allowed. An intentional addition or deletion of up to 0.1% of any gas component does not require a new test. At level 2, the qualification is restricted to the wire system used, single wire or multiple wire. For short-circuiting transfer, qualification covers short circuit only. For spray, pulse, or globular transfer, qualification covers all three of those modes. For waveform-controlled welding at level 2, the power source manufacturer and waveform control mode are recorded on the WPQR. A change of manufacturer or waveform control mode requires a new test. For pulsed mode without waveform control, the power source manufacturer is recorded but a change of manufacturer does not require requalification. Similarly, for welding without pulsed mode and without waveform control, manufacturer identification is required but a change does not trigger requalification. GTAW, Clause 8.5.3. Shielding gas. Qualification restricted to nominal composition, with a deviation of up to plus or minus 10% relative of the helium content permitted. Welding with filler material does not qualify for welding without filler material, and vice versa. These are separate qualifications. Plasma arc welding, Clause 8.5.4. Qualification restricted to nominal composition of both the plasma gas and shielding gas. With filler and without filler are separate qualifications. If impact tests are required, a change in the type of joint preparation requires requalification. Backing gas, Clause 8.5.6. At level 2, a butt weld test without backing gas qualifies welding with Group 1, N1, N2, and N3 backing gas per ISO 14175. But a test with backing gas does not qualify welding without backing gas. The restriction runs in one direction. For material groups 1 to 6, changes between Group 1, N1, N2, and N3 backing gases do not require requalification. For material groups 8 and 41 to 48, changes between Group 1, N, and R backing gases do not require requalification. For material groups 7 and 10, any change in backing gas classification requires requalification. If production welds are made on a material backing support thicker than 5 mm, deletion of backing gas is acceptable. Recap, Lecture 8 Key Points 60. Welding position. Any position qualifies all positions when impact and hardness not required, otherwise 2 test pieces needed. 61. Vertical down, PG, PJ, JL045, must be qualified by a specific test piece. 62. Level 2 filler. Same mechanical properties, same covering type, same nominal chemistry, same or lower hydrogen. 63. Low temperature impact, less than -20 degrees Celsius. Level 2 restricts to specific filler manufacturer trade name. 64. Heat input at level 2, upper limit equals 125% of test value. For impact, lower limit equals 75% of test value. For hardness. 65. Heat input at level 1. Maximum is the maximum actually used, no tolerance above. 66. Preheat decrease greater than 50 degrees Celsius requires requalification. Interpass increase greater than 50 degrees Celsius requires requalification. 67. Addition or deletion of PWHT is never permitted without requalification. 68. GWAW at level 2, waveform control mode and manufacturer locked to the test. pulsed, non-waveform. Manufacturer change does not require retest. 69. GTAW. With filler and without filler are separate qualifications. Quiz Lecture 8. Please comment answers in comment section. Question. At level 2, a procedure test was performed at a heat input of 1.5 kJ per millimeter with hardness requirements specified. What is the minimum qualified heat input in production? Question 2. For a GMAW, process 13, procedure qualified using short circuit transfer mode, which other transfer modes are also qualified? Question 3. At level 2, a GTAW procedure test was performed without filler material. Which of the following is correct? Thanks for watching. Previous lectures is available in playlist.